In this screencast I'm going to look at how to resolve a force into two perpendicular components. And the force I've chosen is this vector v here. It's denoted by the symbol v, and it's drawn in the diagram. It's at this angle theta to the horizontal in the second quadrant. And I've also got the I and j unit vectors drawn here, and what we're asked to do is to find the I and j components of the vector v. So let's first of all look at the I component. The I component is, and in fact any component of a vector in a particular direction is always, it's defined to be the magnitude of the vector multiplied by the cosine of the angle that we have to swing the vector through in order to align it onto the axis that we're interested in. And so in our case, what we would have to do is swing the vector v all the way round through an angle of pi minus theta to have it pointing in the same direction as I. So what I do is I put pi minus theta in that bracket here, and that is an expression for the I component of v. I can simplify that because the cos of a minus b, that's the standard trig identity. It's cos a cos b plus sine a sine b. And then in fact I can simplify that further because sine of pi is 0 and cos of pi is minus 1. So in fact the I component of v is minus the modulus of v cos theta. And you ought to check that that does make sense. Should v have a negative I component? And I hope you can see that it should, because v is pointing in the left rather than the right hand direction. It's in the left hand direction, and so we would expect it to have a negative I component. You could, if you wanted to, stop the screencast now and see if you can write down the j component yourself. I'll do it for you now. So this is the j component of v is, and so just as before, it's the modulus of v times by the cosine of the angle that we have to swing through. And now the angle that we have to swing through is just this angle here. In other words, oops, that's going off the board slightly, it's pi by 2 minus theta. And that will align the vector v with the j axis. And I would expect this component to be positive because v is pointing upwards rather than downwards. So in here I put pi by 2 minus theta. And then I can simplify cos plus sine, and sine of pi by 2 is 1, and cos of pi by 2, is 0, beg your pardon. And so I have the modulus of v sine theta as being the j component of the vector v. And that answers the given question. I wasn't asked for it, but if I wanted to, I could now write out v in its component form. Its I component was minus modulus of v cos theta, so that's its I component, and its j component was the modulus of v sine theta. So that is v expressed in component form, which wasn't requested, but it's quite nice to put that in as well.